Okay. I know possibly this is maybe more notes in this class than you've taken in Algebra 2. I don't know that for sure. But the first thing that we want to talk about, I don't think we need to take the time to write down. And so this is what 1.4, the beginning, looks like. One way that we can combine functions is we can just add them together, subtract them, multiply them, and divide them. Okay, and so we can put functions together that way. So if I wrote f plus g of x, what does that imply? That you're doing what? Just, what's that symbol there? Adding them, okay? And so down here, if you look at example 1 in the book, we're going to just use that as an example. If I asked for the function f plus g, that would simply be x squared plus the square root of x plus 1. That's all there is to it. If I asked what was the function f minus g, what do you think that would be? X squared minus the square root of x plus 1. If I did f times g, it would just be x squared times the square root of x plus 1, and so on. Now, the one thing that we should be careful of is that when you make these new functions, you have to find the domain that is restricted, and that becomes the domain of the new function. Does x squared have any restrictions on it? Meaning, can you put anything in there? Yes. Yes. Okay. So this doesn't have any restrictions. How about the square root of x plus 1? It does. It can't be less than -1. Agreed? So if I were to find the domain of these new functions, they would have a domain of -1 to infinity because this is in there. Okay. Even though that isn't the function itself. So that's one way that we can put functions together. The main thing I want to talk about today is composing functions. And so composing functions is a little different. Composing functions isn't multiplying, dividing, adding. Basically what composing functions means is they're written this way, f, and this is like a little circle. It's a circle. It's not a multiplication sign. F, I say of f of g of x, and I actually prefer to write it this way, f of g of x. Has anybody seen that before? Okay. When you're composing a function, what this means is you're actually taking an entire function. You see how the entire function is where the x used to be? So you're taking an entire function and you're putting it in for f. Okay? So let's draw a picture. Over here, I'm going to have some x values. Over here, I'm going to have a function g of x. And in a second, I'll talk about if that function is something, how it would work. Then over here, I'm going to have f of g of x. So really what happens, if you were doing the math part, is you take some x value, let's say it's 2, and then you're going to put it into the function g. G is going to output something, agreed? Okay, let's say g was x squared, okay? And let's say I put 2 in. What would it output? 4. What then happens is you take the output, that 4, and you put it into another function f. What that gives you is f of g of x, because you're taking the output of g of x and you're putting it in the function f. What we can do, though, is we can actually make a new function that instead of doing 2 steps, it takes us from here all the way to here. Okay. So, let let me think of a function. I said x squared. Let's just play around with this a little bit. Let's say g of x was x squared. And let's say I said f of x is x plus 5. Okay. So let's take some values over here. Give me a number. Joey. 4. Okay. If I put 4 into this function, what's g of 4? 16. If I put 16 into this function, what would it be? Okay. Is that making sense how it works? You're not putting the 4 into f of x, you're putting the 4 after you've inputted into another function. Okay, let's do another one. How about -3? If I put it into g of x, what would happen? It would output 9. Put 9 into here, I get 14. Can somebody tell me, instead of doing two separate functions, how could I get from here to here in one function? Write a new function. I'm going to call it f of g of x. X squared plus 5. Exactly. Think about that. I squared it, and then I added 5. I squared it, and then I added 5. So my new function, f of g of x, that would take this all the way to here, would be x squared plus 5. Really what's happening, I'll show you, is when you take f of g of x, this is what I tell people, is I go and look at the function f. What was the function f again? X plus 5. And instead of writing x plus 5, I write a parentheses plus 5 and replace. Because isn't this where x normally is? In f of x notation? Yeah. Okay. So I put a parentheses there, and then I put the entire function g in that spot where x was. What's the entire function g? It's x squared. Okay. Now, one thing that you need to know is that if you go backwards, let's say I did this first and that second, it would not produce the same result unless they're inverses. We'll talk about that in a couple days. This is what I mean. Let's say I put 4 into here first. Remember how I put 4 and then I got a 21 on that? Okay. 4 plus 5 is 9. 9 squared is 81. Okay, so what I want to write here is a big note. Compositions are not commutative. Yeah, I can. As soon as I'm done writing it down. This is not commutative. Remember that commutative properties that we've talked about in algebra? You can change the order and get the same thing. Compositions are not. So f of g of x does not necessarily equal g of f of x. But while we're here, let's write what a function for this one, g of f of x, would be. So this time I'm going to take the function g. The function g is x squared, agreed? So I'm going to write at parentheses squared. I am now going to put the entire function f into there. So that would be x plus 5. Okay, if I were to simplify this, x plus 5 squared is x plus 5 times x plus 5, right? It wouldn't be x squared plus 25, it would be That? Okay. All right, so we can see that these two are not the same thing, not commutative. Cool. Let's try one with some basic functions. Let's let f of x be e to the x and g of x be the square root of x. Let's write a rule for f of g of x. I'm going to write it this way just because you might see it in the book this way. As I said, I prefer the other way because to me it makes more sense. I'm actually seeing the function put in another function. But this is the same thing as f of g of x. Does anybody want to try it? If I put the entire function g into the function f just for x, what would you get? It's not going to look pretty, I'll tell you that. Joey? Yeah, so the x is right here. If I put that square root in there, it would be e to the square root of x. By the way, what do you think the domain of that would be? Because square root's in there. 0 to infinity, because of that square root in there. Okay. Alrighty, let's do the other way. How about g of f of x? The same way. Now I take the g, you don't have to write the parentheses down. I like to write the parentheses down. Because then it tells me where I'm putting it. What should go in here? E to the x. E to the x. All right. I'd like you guys to try this one. I'm going to let f of x be x squared minus 5 and g of x be the square root of x. Would you try to write a rule for f of g of x and g of f of x? I'm going to just give you a second to try it on your own. Alright, so for f of g of x, okay, can I simplify that at all? What happens when you square the square root of x? Yeah, so this simplifies to x minus 5. G of f of x, I wrote the square root, and then I put f in for x. Can you simplify that one at all? How are we doing? Any questions so far? Now that we do composition, What if I gave you a composite function? Could you figure out the two functions that made it up? Okay. By the way, these sometimes have more than one answer. Okay? I'll try to start with one that you can see pretty clearly. All right, find two functions, f and g, such that h of x is f of g of x. The first one we'll try is parentheses x plus 1 squared minus 3 parentheses x plus 1 plus 4. We'll try that one first and then we'll try another one. Okay. What do you think? Anybody want to try it? Yeah. Yeah, one of them would be x plus 1. He sees that x plus 1 there. You see that? Okay. Do you know which one it would be? Yeah, it's the one that I'm putting into the other function. So it would be g of x, x plus 1. What am I doing with that x plus 1? Go ahead. Yeah, so if these x plus 1s were x's, that would be my f of x function. So what would it be? All right. If I had put that x plus 1 in for x in these spots, I would have x plus 1 squared minus 3 parentheses x plus 1 plus 4. That's what we see up there. Okay, let's try another one. This one does have more than one answer. What if I said the function the square root of x cubed plus 1? Carmen, what one function do you see in there? You see an x cubed plus 1, yeah. What else do you see in there? A square root. So maybe if I did this, the square root of x? Good. And then x cubed plus 1 is going into that. Yeah. Can anybody tell me another way it would work? Yeah. No, but you can make it the square root of x plus 1 and x cubed. See how that would work too? So sometimes there's more than one way to get them to work. All right.